Welcome to the Diagnostic Clinic. I'm your host, and today I'm putting on my white coat to act as your lead physician for your Cambridge Computer Science exam strategy. We're looking closely at the syllabuses for 0417, 0478, 2210, and 9618, and we are about to diagnose the exact symptoms of a failing exam answer. But more importantly, we are going to prescribe the definitive, foolproof cure. Today's specialist subject, hexadecimal representation. Now, you might be thinking, oh, hex, I know that. But listen, it's a topic that appears constantly, yet it causes an absolute massive hemorrhage of marks every single exam series. We're going to fundamentally transform the way you approach these questions. Because mastering hexadecimal, it isn't just about memorizing base 16 and writing it down, it is all about the structured thinking required to satisfy the examiner's extremely specific demands under immense time pressure. You need to think like a strategist, and that's exactly what we're going to build today. Okay, let's take a quick look at our treatment plan for this session. We'll start with the hexadecimal problem, taking a hard look at why students bleed marks in the exam hall. Then we'll uncover the 3 layers of understanding, tackle the critical difference between description and explanation, and deploy our signature technical exam method. Finally, we'll run an interactive workshop on avoiding common errors and leave you with the ultimate diagnostic check. It's a structured journey designed to turn rote memorization into a high-scoring, bulletproof exam strategy. Let's get right to it.
Section 1. The hexadecimal problem.
Let's step directly into the examination room and look at our first major hurdle. Picture the clock ticking, the tension building. The absolute biggest problem students face is memorizing vocabulary without actually understanding the digital problem that hexadecimal solves. To illustrate this, let me introduce you to 2 students whose past papers are currently sitting on my diagnostic table, and they are just covered in red ink. First up, we have Alex. Now, Alex suffers from a severe case of fact overload. When asked a question about hexadecimal, Alex just panics and dumps raw computer science facts onto the page. He writes down symbols 0 through 9, A through F, it's base 16, but he provides absolutely zero analysis of the context. Then we have Sam. Sam's symptom is the rush. Sam races through the paper, completely misses the crucial command word requirements, and gives a super basic definition when the examiner explicitly asked for an evaluation. Side by side, their answers are failing entirely because they treat hexadecimal as an isolated, boring definition rather than a real-world solution to a massive digital problem. So I challenge you right now, think about this. What practical problem does hexadecimal actually solve in a real device? Before we introduce any heavy terminology, we need a reason to care. The fundamental issue in computer science is that computers only understand binary, right? Ones and zeros. But humans? We are absolutely terrible at reading long strings of ones and zeros. If a network technician has to type out a 48-bit MAC address in pure binary, the chances of them making a transcription error are astronomically high. Hexadecimal solves a human-computer interaction problem. That's the secret. It condenses long binary strings into shorter, more manageable chunks, making it so much easier for humans to read, write, and debug without making those catastrophic mistakes.
Let's look at where this concept actually lives out in the wild. The exact same patterns behind hexadecimal representation appear in your smartphones, in HTML color codes on the websites you visit every day, in memory dumps within massive databases, in automated factory systems, banking infrastructure, and even robotics. When you repeatedly connect hexadecimal to familiar, everyday technology, it becomes infinitely easier to remember why the concept exists at all. It converts abstract memory into practical usefulness. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so as I was saying, for example, when you see a hashtag followed by 6 characters to pick a color on a website, like hashtag FF0000 for red, that's hex. When you look at the physical hardware address of your phone's network card, that's hex. Recognizing these real-world contexts is the absolute first step in upgrading your exam answers from generic robotic responses into specific, high-scoring analysis.
Section 2. The 3 layers.
Moving forward in our diagnostics, we have to recognize that exam mastery is not just one simple giant leap. It requires purposefully moving through 3 distinct layers of understanding. And listen closely, because this is exactly where we separate the passing grades from the absolute top-tier A-star performances. You can't just know what a word means. You must know how to deploy it as a tactical weapon in the exam hall. Notice how clearly this matrix maps out the student experience. Look at Layer 1, simple and everyday language. This is where you understand the basic concept. You might say, hex is a shorter way to write binary. Great, that's true, but it absolutely will not score highly. Then we move to Layer 2, technical vocabulary. This is exactly where our first student Alex usually stops and gets stuck. Alex writes, hexadecimal is a base 16 number system using 0 to 9 A and F to represent 4-bit nibbles. Better? Yes, but still not enough for top marks. Now, layer 3 is the exam layer. This is scoring under immense pressure. This is where you take layer 2 and you shape it into a perfectly targeted response that directly answers the specific command word in the specific context of the question. Students so often think they know a topic inside out because they mastered layer 1 and 2, but they completely freeze and panic when forced to operate in layer 3.
Section 3. Description versus explanation. To effectively get to that coveted layer 3, we have to pivot to an absolutely crucial boundary in Cambridge computer science exams: the fundamental difference between merely describing a concept and actually explaining it. This is exactly where our second student, Sam, loses all those critical marks. You see, Cambridge examiners use very specific assessment objectives, and if you don't decode their command words correctly, you are literally just leaving marks on the table. This slide brilliantly illustrates the difference. A description simply tells the examiner what the device, process, or method is. An explanation, on the other hand, tells them exactly how it works and why it actually matters in the real world. This is a hard, rigid boundary. If you skip straight to explanation without describing the concept first, your answer just sounds confused and disjointed. But if you only describe, like Sam always does, your answer feels safe, but it's incredibly shallow and won't get you past a C grade. Let's actively transform Sam and Alex's answers right now using the ultimate weapon, the PEAL framework. That stands for point, evidence, explanation, link. If the question asks to explain why hex is used for MAC addresses, Alex writes, hex is base 16. Okay, that's a point, but absolutely nothing else. Red mark. Sam writes, hex is used for MAC addresses because it is shorter. That's a point and a little bit of evidence, but no real explanation or link back to the problem. Red mark again. Let's rewrite this live for layer 3, meticulously applying PEAL. Point. Hexadecimal is used for MAC addresses because it represents 4 bits of binary with a single character. Evidence. A bulky 48-bit MAC address is dramatically reduced to just 12 hexadecimal characters. Explanation. This significantly shorter representation makes it infinitely easier for human network administrators to read, write, and configure network devices without visual fatigue. Link. Therefore, it drastically reduces the chance of catastrophic human transcription errors when manually setting up the network infrastructure. Boom! Green check marks across the board. That right there is the computer science success blueprint in action.
That incredible transformation happened for one simple reason: we respected the boundaries of the subject. Remember this quote: computer science reasoning becomes much stronger once boundaries are understood clearly. Knowing the strict difference between describing and explaining, or memory versus storage, or data versus information, often entirely controls the success of your whole exam answer. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @AceTheExams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions. Remember, if you don't know exactly what the examiner is asking for, you might write a truly brilliant, eloquent answer to a question that simply wasn't on the paper.
Section 4. The technical exam method. Let's see how this all builds into our ultimate prescription, the technical exam method. We're going to introduce a very specific, highly disciplined path to answering exam questions, rather than just throwing facts at the page in a random order and praying something sticks to the mark scheme. Let's look at the teacher walkthrough methodology. Step 1. Identify the demand. Decode the command word. Is it state, describe, explain, or evaluate? Step 2. Classify the concept. You say to yourself, okay, this is a hexadecimal question relating to error tracking. Step 3. Explain the sequence step by step. Order absolutely matters in process-based topics. Step 4. Connect to context. Does the question mention a school, a factory, a website? If it does, you must use that context. Let's test this method right now with our first interactive workshop challenge, the data scan. Imagine a highly complex data table on your screen showing a memory dump from a crashed program. I'm putting 60 seconds on the visual clock right now. Your challenge is to extract the core trend. Look closely at the data. 50 seconds left. Notice how the columns are full of 2-character codes? 40 seconds. Ask yourself, why aren't they in binary? Why not thousands of ones and zeros? 30 seconds. 20 seconds. Got it? The core trend here is that the system state at the exact moment of the crash is represented in hex because human programmers need to rapidly identify memory addresses and register values. If they had to scan through hundreds of pages of pure binary, debugging would literally take weeks. Identifying that human efficiency context is step 4 of our method, and I promise you,
It is exactly how you unlock those elusive top marks.
To make this sophisticated method feel like second nature, you need a high-quality revision cycle. It involves 3 distinct, deliberate passes. Pass 1 is where you secure your core definitions and key contrasts. Pass 2 is where you actively rehearsed worked explanations, truth tables, and system sequences, exactly like we did with that MAC address peel paragraph earlier. But Pass 3? That is where the absolute magic happens. Pass 3 focuses entirely on adaptability. You actively change the context. You mix nearby confusing terms. You force yourself to justify your choices in totally new, unfamiliar scenarios. This layered structure is incredibly powerful in computer science because knowledge is always reused across different chapters.
Section 5. Avoiding common errors. Now, we're shifting gears to some serious examiner insights. I'm pulling back the curtain right now to warn you about the surface distractions that cost unprepared students easy marks every single year. It's time for Challenge 2 in our interactive workshop, Find the Flaw. The crucial point here is recognizing these common mark traps. We're talking vague wording, missing critical sequence steps, stating an advantage without giving a reason, and the absolute biggest exam killer of all, generic, context-free responses. Let's do the Find the Flaw challenge together. Here is a sample paragraph from a real student's mock exam. The automated factory uses hexadecimal for its error codes because hexadecimal takes up less storage space on the computer. Okay, where is the flaw? I'm giving you 10 seconds to spot it. Tick, tock, time's up. Did you catch it? The massive flaw is that hexadecimal does not take up less storage space. A file stored on a physical hard drive takes up the exact same amount of physical space whether you as a human view it in binary, denary, or hexadecimal. It is physically stored as binary magnetic states on the disk. The student completely confused the visual human representation on the screen with the actual physical machine storage capacity. The examiner commentary on this mistake would be absolutely brutal. The correct answer should solely focus on the factory technician being able to quickly read the error code off of tiny LCD screen without making a transcription mistake. The context matters. Don't fall for the storage trap.
This brings us to a really profound realization for your study habits. Error-aware notes are more useful than notes that contain only correct facts. You need to know exactly what a trap looks like before you walk into the hall. You must actively avoid jumping forwards and backwards when describing a process, or mixing general theory with the context in a way that breaks the logical flow of your answer. Let's dive into Challenge 3, Speed Writing. You have 30 seconds on the visual timer starting right now. I want you to write one perfect peel paragraph explaining exactly why a web developer uses hexadecimal for HTML colors instead of binary. Go! Okay, think. Point. Web developers use hex because it represents 24-bit true color depth using just 6 simple characters. Evidence. For example, pure red is represented as FF0000 instead of a massive, unreadable 24-digit binary string. Explanation. This much shorter format is incredibly easier for developers to quickly type, copy, paste, and identify visually when they are buried within thousands of lines of complex website code. Link. Therefore, this significantly speeds up development time and drastically reduces formatting errors on the live website. And time's up. Listen, if you structured your thought process exactly like that, applying peel flawlessly under pressure, you are thinking exactly like an A-star candidate.
Section 6. The Ultimate Diagnostic.
We've identified the symptoms, we've carefully applied the treatments, and we've successfully practiced the surgery. Now it's time to prepare for the final, practical self-check to ensure your internal system is completely clean and you are truly 100% ready to face Cambridge hexadecimal exam questions. We are looking at a system that practically guarantees top marks if you rigorously follow the 3 rules: command word decoding, peel framework application, and the time management matrix. Here is your cheat sheet recap. And look at that! The progress bar is finally hitting 100%. This is the 4-question self-check. For absolutely any topic in the entire syllabus, you must be able to sit down and ask yourself, what is it? How does it work? Where is it used in the real world? And why is it better or worse than an alternative method? If you can answer these 4 distinct prompts out loud smoothly and confidently, then the topic is officially ready for examination use. If you stumble on even one of them, you need another cycle of revision.
I'm going to leave you with this one final provocative challenge for today's session. Can you explain the real mechanism of hexadecimal right now? out loud without relying on that safe, memorized textbook wording? Don't just give me the dictionary definition. I want you to explain it to an imaginary network engineer sitting right next to you. Tell them the point, give them the evidence, walk them through the explanation, and link it back to their daily job. If you feel any hesitation in your voice, go right back to layer 1 and start your diagnostic cycle again. Because true knowledge isn't just about what you can passively remember, it's about what you can clearly, effectively, and accurately communicate when the exam pressure is on. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams, at @AceTheExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @AceTheExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Thanks for joining me in the Diagnostic Clinic, and I will see you in the next explainer.